Hi, welcome to our group assignment presentation. The topic that we are presenting today is combating COVID-19 outbreaks, and this is actually the third milestone or the part C of the assignment submission. And the topic for today is processing of data assignment. Before we begin, let me introduce our group members, comprises of Azwa bin Kamaruddin and myself, Hon-Loong. In this assignment milestone, as you can see, this is actually the third part of the assignment that we have actually presented. Subsequently, there will be two more milestones that we will need to complete. However, for this particular assignment itself, our key focus is to demonstrate how we are able to access and process the data from Hadoop data warehouse or using data lake by leveraging on the Python programming language. Let us go through some of the background that we have actually went through in our assignment. From the previous assignment milestone, our group have demonstrated and accomplished the following tasks. In milestone 1, we have demonstrated our methods in acquiring the near real-time data using the web crawling approach, by also using the Python programming language and the Beautiful Soup package that we have incorporated. In our milestone 2, what we have done as well is demonstrating the steps of how we have stored the data that we have crawled into our cloud storage, also known as the data lake. And also, at the same time, we use the Hadoop data warehouse, leveraging on the data prop that we have configured using the implementation that was provided by Google Cloud Platform, or in short, known as GCP. However, throughout the milestone 2 assignment, we realized that if we actually use the data prop in configuring our data warehouse itself, the credit that was actually being given us to use are being utilized very quickly, and as a result, it kind of utilized the free credits that we are entitled to use for these academic purposes. So as a result of that, in this particular milestone 3, our group will be demonstrating, how we're going to use Python coded with Jupyter Notebook, in accessing the web applications that we have acquired the data, in various different data types. However, in this particular milestone 3 itself, what we're going to demonstrate also is how we're going to change. Instead of using the data prop that we have set up, using the data warehouse on a GCP platform, we're going to use a different method that will actually save us from utilizing the free credit that we are entitled to use for this academic. In the next few slides, I will be able to demonstrate to you on how we're going to do that. But before I actually go through the next few slides, I would also like to highlight here that our Python codes that we're going to demonstrate in this particular assignment for milestone 3 will also be posted in our GitHub, which is actually as shown in the link on your left-hand side. Now, as I've mentioned, in this particular milestone 3, we're going to change the approach slightly in order to save some of the free credit that we are entitled to use in the Google Cloud Platform. So what we're going to do is to set up the data lake or the cloud storage in GCP. And this next few screens are just the snapshots of how we have actually created the storage in a seamless manner, leveraging on the Google Cloud Platform. So when we actually log into our Google Platform, what we need to do when we need to set up the new storage is to just go through the navigation menu and then click on the create bucket to create the storage container. And for this milestone 3, we're going to name our data lake storage container or the cloud storage as WQD 7005DM-COVID-19-DS. In this particular few next screens itself, what we're going to do is to also share with you some of the simple steps so that if you intend to try out on your own, these steps itself will be able to guide you quite seamlessly in order to build up your own cloud storage or data lake leveraging on Google Cloud Platform. Now, under the compute section next, what we're going to do is to create a virtual machine. All right, and this virtual machine is basically going to allow us to set up our development platform, which I will explain later on. But prior to that, in order to create a virtual machine in Google Cloud Platform or GCP, it's actually quite a straightforward process as well, where what we need to do is once we enter the compute engine, we need to click on the VM instances and then click on the create button. And in this create button itself, what it will do next is to prompt you the window, all right, to help you to set up your VM instances. And over here, as you can see, what we have actually done for our group is to name our virtual machine instances as WQD 7005DM-VM. And for this particular virtual machine instances, our group have decided that we're going to use Ubuntu as the OS with minimal settings. And then what we're going to do is to create these VM instances so that we can install Anaconda with Jupyter Lab for Python. And as you can see from the next screenshot itself, the virtual machine is created. And how can we ensure that? Is by seeing the green checkbox that's being ticked. Now, once we have actually created the virtual machine, in order to access to the VMs that we have created in GCP platform itself, all we need to do is to go through the SSH pull-down menu and then select the Open in Browser window. Once we have done that, the shell command prompt will be prompted, and this is where we can actually run all our Ubuntu Linux command to start installing the Jupyter Lab, as well as the environment for us to build up our development platform. And in order for us to install Anaconda, all we need to do is to go to the site as shown in this screen, where we can actually look at the latest version of the Anaconda distribution, for us to actually access to it. And once we have actually found the latest version, we can actually use the copy URL command on a Linux Ubuntu platform to copy the shell bash script that is actually for Anaconda, that we will be able to download it into our virtual machine platform. And when we have actually complete downloaded the Anaconda from the distribution site, what we need to do next is obviously to check on the download file whether it's actually all in place by using the SHA-256 checksum command, as you can see from the screen or from the command prompt on your left hand side. Now, once we have done that, we can actually start activating the installation by using this command source bash rc command. All right, and to test out the installation and the activation, we can actually then start out the conda list. So let me actually show you some of the command that we have actually created. Now, this is actually the actual command prompt. As you can see, I'm actually opening up that window. And once we have actually installed, like what I've actually mentioned earlier, we can actually start activating the installation by using the bash rc command as shown in this particular command line here. And when it's actually being run, we can then start testing out whether our conda installations are activated. And the best way for us to do this is just by typing the conda list, and this is where it will start prompting you all the packages that we have actually installed together with our Python and Anaconda lab itself. Now, in order for us to also ensure we are able to run our command and our codes to, based on how we're going to retrieve some of the data that we have crawled, online in near real time. The first thing that we would highly recommend to all our users, if this is the first time that you're running, the Anaconda and Jupyter Lab, for our group assignment, we will highly recommend first, for you to install these two important packages. First is to ensure that we are able to install the Google Cloud Storage, package. Reason behind is because we are using the GCP Cloud Storage as our data lake, and in order for our Python code to be able to access and process the data from the GCP Cloud Storage or data lake itself, we need to make sure we need to run this command or to install this package the first time. And in this particular assignment milestone for this session itself, we will also be demonstrating how we're going to acquire a different type of data. And for this case, we're going to also start crawling near real-time or live data from Twitter. And in order for our Python code to access to this Twitter tweets itself, we also need to make sure, if this is the first time we're going to run this Anaconda and Jupyter Lab, we need to install this package known as Tweepy. Now, once we have actually installed all these packages, we can actually start the Jupyter Lab by typing this command, which is Jupyter Lab, with the IP address and the port which we have actually used, which is 5000 during our setup, and this command itself. And to show you how this command is run, I'm actually going to go back to my command prompt again. And as you can see from here, once you have actually activated and test all the installations running successfully, what we did next was to run and to start our Jupyter Lab by typing this command. And do take note that each time when we run this command, which is actually the Jupyter Lab, the token that is actually going to be generated will be different for each instances that we're going to run. So make sure when you actually run your command prompt by starting the Jupyter Lab in your Ubuntu command prompt itself, it's very important for us to ensure that the token that we're going to key in our browser is the right token. And of course, instead of using this WQD, we can actually use the IP address that we have used to set up our Jupyter Lab or the virtual machines in our GCP platform also. And once you have actually successfully run the command, this is where you can see that the Jupyter Lab, the shell will be activated. And what we're going to do next is obviously to copy that token that we have generated and use a browser, all right, and actually paste it so that we can actually start activating this Jupyter Lab, as you can see from my next demo here. Now, this is actually the live Jupyter Lab that we have installed in our GCP platform. And over here, you will be able to see the environment, the whole Jupyter Lab, and also the files and the codes that we have created. Now, in this assignment itself, our group have created 4 sets of Python programming codes. The first programming code is for us to crawl for time series data. The second code that we have used is to be able to demonstrate how are we going to access the time series data that we have acquired using the web crawling method. The third code that we have is to crawl for the tweets from Twitter based on the relevant topics that we have actually inserted in our programming code, so that we can actually then convert it into a JSON data type. And then, of course, the last code in Python is to demonstrate how we're going to access the tweets data. So let me go back into my browser. And these are the codes that we have just mentioned. So this first code itself is to demonstrate how we're going to crawl, the near real-time time series data that we're going to acquire. Now, let me run this code, and this is actually where we're going to. This section is where we're going to start importing all the packages, the library. For this case, because we're going to use the web crawling using the Beautiful Soup, we have also, import the Beautiful Soup package in our code itself. And over here, you will notice that we are going to crawl our near real-time data, from this GitHub site, which is actually the website where Johns Hopkins University is keeping all their near real-time data. And for this case, it's always a day. It's always up to date to a day before we run the code here. This is actually the section where we're going to actually start acquiring all the data. And what we're going to do is then we're going to store it into a data frame, or what we're going to determine as put it into a tabulated data into a data frame. And then we're going to convert this data frame to a CSV format so that we can actually then store it into our data storage. Now, in order to store into our data storage, remember just now we mentioned that we need to install the Google Cloud Storage package. And the reason why is so that we can actually run this command, the !gs util, to copy the CSV file that we have acquired, in a near real time from the website into our GCP Cloud Storage or data lake. So let me run this command. And as you can see, the files that we have actually acquired are now stored. In order for me to demonstrate, the data that we have just acquired. So let me go to the storage section here. And under this bucket, you will notice that the 3 acquired files from the time series that we've acquired have just been copied, which is actually being timestamped as of today with the time that I've just run just now. Now, let us next demonstrate how we're going to access this data as per the objective of this particular assignment itself. So we're going to run our Python code again. And over here, we're going to actually start importing the package. And then we're going to start accessing our data from the data lake that we have stored in GCP platform. And this is where we're going to start putting it into the blob objects. And let us run this code. And over here, you'll notice that we have just read the confirmed cases of the CSV file that we have just acquired from the website. The next section is to demonstrate how we're going to read the data on the death cases. And of course, the next one is on the recover cases. Next, what we need to do is to obviously clean up some of the data. And what our group have decided is to drop the unneeded columns, all right? And then we will just rename some of the headers so that it will be more descriptive, for us to access the data when we actually run the code itself. And over here, we have actually renamed one of the column header, by using the field name country, all right? And then that's where we will actually demonstrate to you how we're going to access the data. Now, the first thing that we're going to do is to share with you how we're going to access the data, for the confirmed cases. And over here, what we're going to do is to, filter out based on the data that we've acquired for the ASEAN countries only. And in order for us to do that, this is actually the set of code, for us to get the data for ASEAN region. And then we will actually start running for our confirmed cases, the death cases, and the recover cases. So let us run the code. And to first start, seeing, our confirmed cases, as you can see, when we actually access to our data that we've acquired, which we stored in our data lake. This is the records of information that is updated up till the day before. As you can see from my computer here, today the date is the 15th of May, and the data that is being updated here is dated as of 14th of May. That's because it required 24 hours for this time series data to be updated, all right? And that's the reason why we say this is a near real-time data that we are acquiring. All right, next we're going to demonstrate how we're going to assess the death cases for the ASEAN country. And again, you can see these are the sets of data for ASEAN countries for death cases till the 14th of May. And for the recovered cases, this is how the results turn out to be based on the data that we've acquired for the recovered cases up to the 14th of May. Now, in order for us to also do some so-called demonstrations of how we can actually do some other access in a different format, because sometimes when we read the table in such a manner, it can be a bit challenging, for us to look at the full data set itself. And for us to make it more presentable, what our team has done is we actually transposed the table so that it will be able to demonstrate, in a format that is more readable. And for this case, as you can see, once we have transposed the data, instead of showing on a very wide table format, now we are actually seeing it in a long manner, where you can actually see it more easier based on the country, which is actually listed on the top, and then the date, based on the records, as you can see from this code itself. The same goes for the rest. We can actually, if you want to, we can actually demonstrate how we actually transpose, the data table for the death cases and also for the recovered cases. So next, let us demonstrate to you, how we have also acquired a different data type, which is actually more from an unstructured manner. And for this case, we would also like to demonstrate to you by using Python code how we actually crawl for an unstructured data from a Twitter website. So over here, this is actually the set of codes that we have used. And this is where we're going to import all the required libraries for us to run this program, for us to crawl the unstructured data from Twitter itself. Now, in order for us to be able to run the API command for Twitter interface, we have to request for a key. All right, and this is actually a key that was generated by Twitter that's being assigned to our group. And in order for us to ensure that we are able to keep the privacy of our key itself, so what we have done was we have actually stored our key in our Google Cloud storage, so that all we need to do every time for us or for anyone who wants to run our code, they can just call the key from our data lake itself. And with this manner, it can actually help us to create a better security for our programming, so that we don't have to key in the actual key that was assigned to us from Twitter into our code, but instead we call it from our data lake itself. And for this case, we have actually stored our code in our storage bucket known as wqd7005dm/-authorization. Next, obviously, we're going to run the code, and we're going to actually start using the API that was actually being authorized to us to call for the Twitter. And this is where we're going to start crawling for all the information related to coronavirus, whether there's a space, without a space, or whether we want to call it as COVID-19 or COVID-19 with a hyphen. All right, and this is how we're going to put it all into our query, and we're going to run it. And once we run that, you can see that this is actually the unstructured format that it has actually crawled back, and we are going to store this into JSON file, as you can see here. Next, in order for us to demonstrate how we're going to access the unstructured data that we have also acquired, and store it into our data lake, which is actually sitting in GCP platform. This is actually the set of code, that we have used, to start, assessing the unstructured crowd data that we have acquired from Twitter. So we import all the packages, the libraries, and we call again for all the libraries. And over here, this is where you can see that the JSON file that we have actually stored into our data lake is actually being inserted into our bucket known as WQD 7005 DM -COVID-19-DS, and we can actually then start putting it into the string and start running the code and to read the JSON file, and tada! Over here, you can see this is actually the file that we have actually stored in our data lake, and we use Python code, right, to then access to the program itself. So this is again some of the screenshots that we would like to summarize of the 4 programming Python programming codes that we have created for our group. And in this assignment, what we have done a moment ago is to demonstrate that we have used the web crawling method with Python codes to acquire varieties of data sets. We have a CSV format on a most structured, and then we have a JSON type, which is a semi or unstructured format. And then we have also demonstrated how we access the data sets acquired using the Python programming language from our cloud storage. For this case, we're using the data lake storage from the GCP platform. So in summary, we would like to actually demonstrate to you on the diagram here on the right of how we have actually acquired the data from various different sites. The CSV file acquired from the Johns Hopkins University, which is stored in the GitHub link, as we have shown in the code earlier. And at the same time, we have also acquired, the data, based on the topic that we wanted to highlight, for this case related to COVID-19, all right, so that we can actually start crawling all this information and store it into our repository, so that we can actually do the acquisitions and exploratory and analysis, through the programming code that we use. And for this particular case, our group have decided to use Jupyter Lab and the Python code to demonstrate how we have accessed the data that we've acquired earlier based on those information data that we have stored in our data lake in Google Cloud Platform. So in a nutshell, within a typical data mining project, there are usually many different types of operation management software with many different data storage as well. So it's actually up to every individual or groups, or for your particular project case, you can choose whatever type of storage, whatever type of method, whether you want to put it into data warehouse or whether you want to put it in data lake. It's all right, but the most important thing is it has to be easier for us to mine and to do our data mining, and then access the informations from our storage that we have acquired the data from. As the number of data sources multiplies, having data scattered all over in various formats prevents the data analyst from seeing the full and clear picture of their current state. So that's why it's also very important, once we have actually acquired the data and store it into our data lake or cloud storage itself, we need to be able to do the necessary data mining and exploratory, so that we will be able to structure our data in the right manner, so that we can assess the data and present it in an interpretable format for our users to view. And lastly, this creates the necessity for us to integrate the data in a unified storage system. And for this case, our group have decided to use the data lake from the GCP platform, where we can actually start collecting, reformat, and use the data, so that it will be always ready to use. With that, I would like to thank you for your time in going through our presentation. Shall there be any questions? We look forward to hear from all of you during our class session. Once again, thank you very much.